We're lucky enough to have with us tonight Professor Richard Kingsford from the University of New South Wales. He's going to talk to us about what he knows.
Thanks, Matt. I'll get you to go back one. Peter, can you just go back one? So I guess I'm just going to carry on the challenges and talk about, some of the next. And again, this, you might not have seen this, but this is the Living Planet Index about what's happening to biodiversity around the world. And if we assume 1970 is the baseline, so that's one, because that's when we started collecting data, and what's happened since then. And you can see in all the terrestrial systems of the world, compared to the marine and the freshwater, we've lost about 60% of our biodiversity in freshwater systems. And Australia is at the forefront or at the back, whichever you like to call it, of that problem. Next. So Macquarie Marshes, for those of you who don't know where this is, given that we're in the catchment here, I'm assuming most of you know, but it is all about connectivity. It's all about what happens at the top that influences the bottom. People talk about rivers dying from the mouth up, and also they talk about transferring wealth from the bottom of a river to the top of the river. You should think about that when we talk about decisions made in river systems. There is a nature reserve there, but mainly the country's owned by landholders, and even in the Australian government has admitted to the international community. You can see the furore at the moment about the Great Barrier Reef and the ability of the current government to admit such things, but we have admitted that the Macquarie Marshes is likely had a change in ecological character due to what humans are doing to this river. And we do have a substantial amount of environmental water in this system. Here's a bit of a 101. I know most of you know what happens to rivers, but I'm just going to run quickly to what the problem is. So if you think about a river system and what happens in this, the water flows down, goes onto the floodplain like the Macquarie Marshes. When we change that river and we put a big lump of concrete, Burrendong Dam for example, in the top of this river system, it allows us to regulate it. We can move flows down that river system, and when we're thinking about Jinjin Weir, this is another form of regulation. And eventually what happens, because we're taking more and more water out of that river, there's less and less to be flooded. Peter? And not only that, it's all about constant control of a river's natural processes. We build levee banks, we build a whole lot of structures. If you just keep going, Peter. We've got off-river storages in this system. And one of the big challenges is, if you live in a certain part of the river, you think that water that's going down the river is going to waste. So this was a quote out of The Land in 1995 from someone at Mudgee. Why is there any water going past my front gate that I can't use? We have had water agencies across this country who have been driven by the fact that they don't like water being wasted in wetlands or going out to sea. We continue to be that way. We have a national party that drives that currently all the way to building bigger and bigger dams. It's a fundamental problem that we currently have in this area. Next. So what happens to the Macquarie? Again, a bit of 101. This is Burrendong Dam. And so what I've got here is just a cut through from the top of the catchment to the bottom of the catchment. And if you think about the environmental flow in a river system at 100%, in a natural system, you will have a straight line. Nothing changes. Next. But in a regulated system, not much happens above that river. Some people have accused me for not knowing how a river works. And when I've asked them where they live, they've told me they live above the dam. And I said, well, your river probably hasn't changed that much. Have you been to visit people at the bottom of the river? Why would we want to do that? So the fundamental thing is, next, is that right in the middle of this, we take that water out that used to go down. And so a place like the marshes at the bottom of the river doesn't get nearly as much water as it used to. Next. So this is some things, keep going, Peter. There's some changes in the Darling River catchments. Next. This is some work done by CSIRO. Next. Just keep going. So you can see the Macquarie in here. In terms of reductions of flows, this is in 2008, so some time ago, and was considered currently around moderate to moderately high under climate change, and I'll come back to climate change. I'll also come back to these figures because I think they're wrong. Next. So flow effects on the marshes. Keep going, Peter. Essentially, this is roughly what's been happening to the marshes. When we didn't have dams and taking water out of this river, we had big flows, little flows, dried, and you know, next time Barnaby tells us that it's going to be droughts and floods, yes, we've always had droughts and floods, but our floods are getting much smaller. That's not the point. Next. This is some work, and just picking up on what Mel was saying about modelling, Uncertainty Matters. There's a scientific paper where we compared the New South Wales government modelling to actual flows in the river at the Macquarie and to a statistical analysis of it. So green here is actual flows, blue is the statistical modelling that we did, orange here is the integrated quality and quantity model, which is IQQM, which New South Wales government had used for modelling the river. Next. So first of all, we looked at what happened before dams. So this is different flows. So this is from high flows to low flows. And I'll just point out a couple of things. These are the percentages of those flows over time. Remember, the green line is natural. That's actual data. The blue line is our modelling of it. It's still, all models are difficult to get. The orange line is a lot lower. Now, the point about this figure that's really important is under the current modelling, or the modelling at that time by the New South Wales government, they considerably underestimated large flows. Like, a lot. Next. What's interesting is that when you did it post-dam, again, Peter, you find that they overestimate flows in a regulated river. They think there's a lot more water in this river than there is. And in fact, it's that green line, particularly even at high flows. So when the Northern Basin Review comes out and says we're going to cut 11 gigs out of the Macquarie because it's over allocated to the environment, no one actually quoted this paper, even though it was in the peer-reviewed literature. There seems to be an ability in the New South Wales government and other governments to completely ignore science, rigorous science. It's about how many different peer-reviewed, of their own peer review, can we do to actually see what's happening? Where is the transparency? Next. So the important part about this, remembering that underestimate high flows in unregulated, overestimate high flows in regulated, and actually they overestimate low flows. What that actually means is that when you do that analysis, their analysis tells us that only 22% reduction in flows in this system, because they're comparing these two models. It's actually about 50%, 43%. Our statistical model gets much closer to that. Next. So what we've been doing with other researchers in the government, next, is actually looking at what happens with flows and flooding in the Macquarie Marshes for a long time now using satellite imagery. Next. And what that allows us to do is say what's happened to the marshes over time, given that we've got such a good relationship between flows and flooding. Next. And you can actually estimate what happens to area of wetlands. You see that's up to 1 million hectares. Next. If you had no dams in this system, and obviously no one wants that because of the flooding issues, it wouldn't have just been the 1950s that we got over 1 million hectares flooded, and that was mapped in the 50s. We would have got that also in the 70s. But because of the dam, next, when you put a dam in this system, you're knocking out a lot of those flows. And your flows and floods get much lower. Next. One of the other things that I do, next Peter, I spend a lot of my time in October doing aerial surveys over about a third of the continent. Each one of these survey bands is 30 kilometres wide, and we have been surveying the top end of the marshes now for this year will be 39 years. And what we've been finding is this long-term decline in waterbird numbers, and that's largely because they're drying out. Next. And more recently we've been surveying all of the other river basins in the Murray-Darling and the major wetlands. Next. One of the major attributes or major values, not just for you in the Macquarie, but for the nation, is what happens to these colonially breeding waterbirds. So these are, next. This is what happens with these egrets, ibis, herons. You need, so you see here annual spring flows in gigalitres, and you see the probability of breeding. You see this relationship where you need to get 200,000 megalitres plus into the marshes before these things go, before they breed. And if we're not breeding them here, there aren't many other places we're breeding them. They do breed in big numbers in the Bullagall system on the Lachlan, but the New South Wales government's going to make sure they don't again by building a big dam there. Next. So, straw-necked ibis. When I talk to Gary, who lives in the marshes, and he tells me how these really clean up the locusts. These are what we call ecosystem services. These are things that nature does for nothing. But the sorts of decisions that have been made in this system mean that nature can't do it because we're knocking them out. Next. And so you have this whole relationship between flows and flooding for a range of different species. Next, Peter. So, we have calculated how much this has affected this breeding, and we estimate that it's taken out about 100,000 nests about every 10 years, the amount of water that we're taking out of this river. Next. So what about colony sizes? Why should we care? Next, Peter. It's worthwhile, this is some work I did a while back, looking at different colony sizes across the country. And you'll see this goes Alligator River, so this is up near Kakadu, Lake Eyre Basin. Next. Just keep flicking through the lot on this one. But you can see that each one of these species, the marshes is where the action is, or was where the action is. One of my big concerns, and I know a lot of locals, particularly people who live in the marshes, is are we going to see these floods again? Are we going to see these massive colonies again? Next. So you can see that on every scale the marshes is outstanding, but we don't seem to be treating it that way. Next. I had a PhD student, Jo Ocock, and I said to her, I want to know how many frogs there are in the marshes. And she said, well, that's a bit hard, but let's work out how many tons of frogs there are in the marshes. So this is flows along here in blue. Next. In red, so these two floods, 20,000 megs, 5,000 hectares flooded, 900,000 megs, the 2016 flood, and 190,000 hectares flooded. So next. So this is tons of frogs, but this is a log scale. So you can see that even in a small flood you get a lot of frogs, but in a big flood you get a hell of a lot of frogs. And you can see, they're one of the engine rooms of this system. In fact, Joe was trying to radio tracker frogs across the marshes, and they moved 1 or 2 kilometres, and then suddenly one of them went about 10 k's, and she couldn't work it out until she tracked it and found it in an egret mouth. Next. Next bit. Oh yes, so these are, some of the species that are really keyed into the flows. Not every species is. Some of the burrowing frogs are more about rainfall. Next. So what's happening to the vegetation? Next. Essentially, you've got these different zones of vegetation in this system. They go from really wet to drier and drier and drier, right till you get a terrestrial system. As this dries out, less water, we're seeing all of these systems, except the terrestrial one, contract. So our terrestrial ecosystems are invading the wet bits because they don't get wet anymore. In an ideal world, we would get a lot more environmental water that would go back and restore this system. That's part of the challenge. Next. The other major issue in this system is not just about the large dams in the top of it. This is the Macquarie, next Peter. This is an area that we did some work in some time ago. You can see the nature reserve there. But you can see there are a lot of structures. The water obviously comes from the south here and goes north. There are off-river storages, there are tanks. There are also a range of levee banks that are changing the way the flows go across. When people talk about Macquarie Marshes, it is a massive system. It is not just those green patches. It is a mosaic of wetland. And that water needs to get through this intricate maze of channels and levees before it gets up into the marshes. 1,600 kilometres of channels there that can intercept flows and change them. Next. And I come now to Gin Weir. Lovely photo. Looks beautiful. Next. And we hear from Water New South Wales that it's going to increase the efficiency. Efficiency is a wonderful word, isn't it? So when Burrendong Dam was opened, the quote at the opening of Burrendong Dam was, "This is going to make for a much more efficient river. We're not going to lose that water in the Macquarie Marshes anymore." And then it's going to do everything. As Mel said, this weir's going to do everything. It's going to give us more water for towns, farmers, stock, domestic supply, and of course, maintain natural flow. No dam has ever done that. I don't see why this one's going to be any different. Next. So increased regulation, what does that mean? It means flow capture, which means decreased flow to the marshes. There's no other way that you can describe what's going to happen. It triggers a whole lot of things that New South Wales didn't want. Matters of national importance under the EPBC Act, so the Commonwealth is looking at this. It's going to affect a Ramsar site. It's going to affect nationally threatened species and migratory species. Next. And that's not the list of the other things. There's all those things that Mel was talking about in terms of native fish species, vegetation, waterbirds, and a whole range of things. Next. Now to the Basin Plan, which I gather the Nationals have tried to blow up today. This is some work that we did recently, wearing my hat on the Wentworth group of concerned scientists, where we looked at the Basin Plan and how much water was going to go back into the rivers, adjusted that for climate, and in an ideal world you would get a plus, a blue number, across different places in the basin. Unfortunately, these are all red. And the Macquarie is 140% in the red. So we were adjusting for dry years as well as wet years. So the plan doesn't seem to be delivering what it said it would deliver in terms of the environment. Next. And it's not surprising that there are these headlines about fish species and bird species being affected and not being delivered. Next. What about our drying climate? We know that the Macquarie got turned off in 2019. Next. Some of you may have seen this article in the Sydney Morning Herald last Sunday. Nothing there in terms of the Macquarie, but the government must have these data because this is for the Namoi, and it's showing what's going to happen to licences, i.e. water in the dams, under 3 scenarios. Observed historical record, blue, black or dark blue long-term climate record, and then long-term climate change. Those numbers are very scary. They're halving. That means there's going to be a huge reduction, potentially, I think around 40%. Next. So we did some work in this Macquarie River, and this is Celine Steinfeld, who was a PhD student of mine, and we looked, you probably can't read that, but it's about the human dimensions of decision making in this river. And we compared the Guaida to the Macquarie. So 2 rivers, same state, same legislation, same water agency, but quite different. How does that happen? And so the question is, these human dimensions are very critical in terms of managing these systems. Next. What makes this even more interesting is that in the Macquarie, the water agency adopts what's called a credit approach. So it decides how much water it expects to go into the dam and gives it out before it's actually rained. Whereas in the Guaida, there's a debit approach. You wait until you've got enough water in the dam before you give it out. Now, the fundamental problem with that is when you've got a drying climate and it doesn't rain anymore, you're in big trouble. And then you say, we've got a real water security problem in the Macquarie and we need more dams. Or if you're in the Lachlan, which they use the same credit model, we're running out of water. The towns are running out of water. How could a politician ignore that? When in reality what's happening is we have a mismanagement problem in terms of managing this river. This is a fundamental problem that most people don't understand. Next. So just to summarise. Next. We're in trouble, as we've heard, in the Macquarie. And there's a whole range of reasons. We've given out too much water, floodplain harvesting, the way we're managing it with a credit approach, all sorts of little rules there that are 50-50 rules but are interpreted not for the river. No one's speaking for the river. The Gin Weir, it's going to be another significant impact on this river system, affecting the plants and animals and the people in the marshes. And climate change is here already, and it's going to give us even bigger problem in this system. Thanks very much.